have seen a lot of things pertaining to segments, line segments. We talked yesterday about midpoints and segment bisectors and how a bisector divided something in exactly one half. You had two equal pieces, right? Remember that from yesterday? Okay? And the midpoint was equidistant from both endpoints on a segment. So today we're going to talk about different things about angles. A lot of the things that we can do with segments, we can also do with angles. Okay? So angles just look different. First of all, an angle consists of two different rays with the same endpoint. So if you look at this picture of an angle right here, this is a ray and this is a ray. And they both have the same endpoint right here. That endpoint is called the vertex. Okay? That's the point where your two rays come together to make an angle. And also you have two sides. The sides are made up by the line parts of the ray. Okay? So that's how we get an angle. It's formed by two rays. It has a vertex and it has sides. How you name an angle is very important. Okay? You need 3 letters to name an angle. The middle letter is where the vertex is. So I want y'all to draw that picture for me, okay? Make sure you put the letters on it because that's the important part. So when you're naming an angle, the order matters. It matters where you put each letter, okay? Because how you rearrange the letters is a name for a different angle. So there are actually 3 angles in this picture. Do y'all see 3 angles? How do I have 3 angles? Yeah, here's one on top, a little one, and here's a little one down here, and then the whole thing is the third one. Y'all see that? Okay, so it's a large angle that's divided into 2 smaller parts. Okay, so there's actually 3 different angles. So the way we name an angle, the symbol we use for angle looks like an angle. It's kind of like a slanted L. So to name an angle, we're going to use a symbol like that. Okay? And the vertex, the letter that's the name for the vertex, is always the letter that goes in the center. Okay, so what letter is the vertex for all 3 angles? X, okay? They're all the rays. These are 3 different rays, and they're joining at the point X. So the X is going to be in the middle of every name, okay? So let's just talk about the top little angle first, okay? The way you name it is you take the 3 letters, okay? 2 of the letters come from the sides, and the vertex is in the middle. So one name for this angle would be WXY. Y'all see that? This top little angle, one name could be WXY. The same angle could also be called YXW. Okay? So you take the 2 letters that are on the sides, and the one in the middle is always in the middle, but you can reverse those 2 letters. Okay? So one name for that angle is WXY. But X is always going to be in the middle because X is the vertex. Can somebody tell me one of the names for this angle down here? YXZ or ZXY. Okay? But make sure when you're naming an angle, you put the little angle symbol. YXZ. The third angle in the picture is the large angle. So somebody tell me a name for the large angle. Is Y part of the large angle? No, because it's not on the edges or the sides of the large one. So you could say ZXW or you could say WXZ. So make sure you have the angle symbol. And y'all, I apologize. Sometimes mine look like L's. I know they do. Yeah, so if yours do, it's okay. Some people are like really, really sharp with theirs, and theirs look really good. Mine does not look like that usually. WXZ. Z. But I've had students before that theirs always look just so perfect and mine just do not. Okay, so that's how you name an angle. Any questions about that? Okay, the vertex is always in the middle, and you need how many points to name an angle? 3. Good job. All right. We've got 4 different kinds of angles. So you might want to just draw a quick sketch of these. And I think this is stuff y'all have seen before. Right? Have we heard of these kinds of angles before? Maybe like 7th or 8th grade? Because to my knowledge, I believe there's a lot of geometry concepts that are covered in 8th grade now. Do y'all remember doing some, like perimeter area? You slept a lot since 8th grade? You don't? You blacked out that year? Okay, I won't let you take me talk any further. We have video evidence. They can't hear you. So have we heard of acute angles before? Right. What do y'all know about an acute angle? It's less than 90 degrees, so it's smaller than a right angle. Okay? So that means less than 90 degrees. Y'all know what that means, right? Less than. Okay. It looks like angle 90 degrees, but that one actually means less than. So a picture of an example of an acute angle would be like this one right here. That little angle it makes is less than 90 degrees. What is a right angle? It's exactly 90 degrees. Okay? So it actually looks like a really straight vertical and horizontal. They could be tilted. So don't think just because it's vertical and horizontal looking that it's a right angle. They could be shifted sideways. We usually indicate that by putting a little square in the corner of that angle. Okay? So that's how we indicate right angles usually, is by putting a little square at the vertex. And it's exactly 90 degrees. Yes, they are. All right. Y'all know that an obtuse angle is going to be what? Larger than 90 degrees, right? So it's larger than a right angle, but it's less than 180 degrees. Larger than 90, but less than 180. That's why it's written like this. If you see what you're looking for between two numbers like that, that means it's between those measures. So that's what this means right here. It's between 90 and 180 degrees. Okay, so written like that with those less than, that's what it means. It goes back to inequalities from Algebra 1. Because I know we did inequalities in Algebra 1. Every one of us did. All right, so one usually looks like this if it's obtuse. See how it's going back further than 90 degrees. The last one is called a straight angle. A straight angle is just a line. Okay, a straight angle is a straight line. It's exactly 180 degrees. Okay, a straight angle is a line, and it's 180 degrees. Simple, huh? All right, and I'm going to skip some stuff if that's okay with you. Right? Next thing has you talking about protractors, and I'm going to skip it. We're going to go to the angle addition postulate. We did the segment addition postulate yesterday, didn't we? And I remember I told you that a simplified way to memorize the segment addition postulate was that little segment plus little segment equals big segment. We did that 2 days ago, I believe. Little segment plus little segment equals big segment if we have a segment broken into parts. Well, the angle addition postulate is if we have a large angle that's divided into two smaller angles. So, for instance, this one, they have a ray SP that's dividing this into two parts. Now, they're not two equal parts, are they? No, you can't assume that they're two equal parts. Okay? So, we have one large angle that's divided into two smaller angles. So, the large angle is angle RST. And it is broken up into angle RSP and angle PST. So if I wanted to find the measure of the large angle, I would do little plus little equals the big, right? So if I take this measure and add it to this measure, that will tell me the measure of the whole big angle. So that's basically the same thing as segment addition postulate. Little plus little equals big. So this one is the big one. And it's going to be the little angle plus the other little angle. So that's just my simplified way of doing segment addition. Little plus little equals big. You add the two little angles, it'll tell you the measure of the larger angle. Okay? All you got to know from that. Little plus little equals big. Then we get to actually do some math. I'll let you write all that down. Draw the picture. If you can't read it, this measure is 2x plus 10 degrees, and this one is 4x minus 3 degrees. Yeah, and we're doing it with angles. Yeah. We're going to do the same thing we did with angles as we did with segments. So everything we did with a segment, we're going to do it with an angle now. But yeah, this is still two little angles making a big angle. Just like it was, except the picture just turned a different way. And the angles might be bigger or smaller. See, like this whole thing looks like an obtuse angle, right? The whole thing looks more obtuse. The other one was all acute angles. It says find the measure of angle LKM and MKN. So LKM is this little angle up top, and MKN is the other little angle. Okay? Yes, ma'am. Okay? So that's what we're finding. We want to find the measure of this little angle and this little angle. What about the measure of the whole big angle? Yeah, but did they tell me that? Yeah, they told me the measure of LKN, which is the big angle, and that's 145 degrees. Now, here's something we cannot do in geometry class. We cannot be too lazy to look at letters. Okay? It says, given the measure, that's what the M in front of the angle means. The measure of angle, LKN. Okay, stop right there. Look at the figure and tell what LKN is. LKN, that's the big angle. All right? You've got to read your letters and actually look at the figure and try to figure it out. Okay? LKN. If you don't do that, you're not going to have a clue what to do in any of geometry. Y'all, this is week 1. Week 1. You've got, symbols are important and you've got to follow pictures. LKN. LKN. So the whole big angle is 145 degrees. They just told me that. They want me to find the measure of LKM, which is this little angle, and MKN, which is this little angle. Now, before that, I got a bunch of X's, don't I? Right? So I've got to find what X is. I don't know what X is. I don't know what this is or anything. So to find X, I got to write an equation. just like we did yesterday. So it's going to be a little different. Little plus little equals big. And I know the big angle is 145 degrees. All right? So I take this little angle, which is 2x plus 10. It's okay that I don't know what x is right now. I'll figure it out. And then I'm going to add that to the other little angle, which is 4x minus 3. And set that equal 145. So this was a little angle. This was a little angle. I can add them together and get the measure of the big. And that's going to help me find out what x is. So, on the same side of the equal sign, I got two different x's, so I combine like terms. What is 2x plus 4x? 6x. Same thing with 10 and negative 3. Those are like terms. So what is 10 minus 3? So 6x plus 7 equals 145. I'm going to erase my line. It's junky looking. Then I'm going to subtract 7 on both sides. So what's 145 minus 7? 138. And then I divide both sides by 6. And x equals what? Y'all got calculators. 23. So x is 23. Does that tell me a measure of an angle, though? No, I got to plug in for x and get those. So let's do the top one first. The measure of angle LKM is going to be 2 times x, which is 23. So 2 times 23 plus 10. What's 2 times 23? And what is 46 plus 10? 56 degrees. So make sure if it's a measure of an angle, you put a degree sign with it. And then the other little angle they want us to find the measure of is the measure of angle MKN, which is right here, and that's 4x minus 3 degrees. So I say 4 times what was x? 23 minus 3. What's 4 times 23? 92. And 92 minus 3 is what? 89 degrees. Now, how could I check to see if those are right? What should I add to equal? 145. So if I add the two little ones, they should equal the big one. Right? Do they? I think so. Okay? Little plus little equals big. Okay? Little plus little equals big. Any questions so far? You need to go back and get the beginning of notes. You're going to have to go back and get the beginning of notes. I covered a lot. I'll tell you right here. All right, y'all write down this next one. It's helpful. Otherwise, why do you take notes? Notes are supposed to help us work problems on our own and study. It tells me that angle LKM is a straight angle. What is another word for a straight angle? 180 degrees, and it's also a what? A line. A straight angle is the same thing as a line, and it's 180 degrees. So the big angle on this is going to be 180 degrees. Y'all see that? Right? The big angle is 180 degrees. That means the measure of angle, KLN. And this means the measure of angle. That really looks like an L, doesn't it? See, I told y'all. Is that better? Oh, that's green. On my screen, it looks black. Is that better? Yeah, my handwriting's terrible. I hate when they have L's and angles anyway. It really makes it confusing. So the measure of angle KLN, which is this one, KLN. So this is obtuse looking angle right here, and the measure of angle LMN, which is the acute one. So we're going to use this being a straight angle, which is 180 degrees. We're going to do little plus little equals big, solve for x, and then find the measures of the two little angles. Okay, just like we did. So somebody tell me the measure of what one little angle is. Read me the blue. 10x minus 5 is one of them, right? Plus, what's the other one? 4x plus 3. And together they're going to add up to be how many degrees? 180, because it's a straight angle, which is a straight line, and all lines are 180 degrees. Okay? So again, combine like terms. 10x plus 4x is what? 14x, good. Negative 5 plus 3 is what? Minus 2 equals 180. Then what can we do to solve for x? Add 2. So 14x equals 182. And then we divide both sides by 14. And y'all can help me do that. It's how much? Perfect. X is 13 degrees. But I still got to find the measure of those angles. So how do I do that? Plug them in. So for the measure of angle KLN, it's 10x minus 5. So I say 10 times 13 minus 5. What's 10 times 13? 130 minus 5 is what? How much? 125 degrees. Make sure you put degree symbols with your measures of angles. Okay, 125 degrees. So there's two ways I can find the measure of angle in LM. Can somebody tell me one way we could do that? Subtract what? Yeah, you can say, since we know the whole thing is 180, right? And this part we just figured out was 125 degrees. If I want to find this one, I can say 180 minus 125, right? Right? Or I can plug it in for x just like I did the other way. Does that make sense? What I usually do is work it one way and then check it the other way. So the quick way, I think, is 180 degrees minus 125 degrees, which is how much, Trey? 55 degrees. Or I can check it 4 times 3 is 52 plus 3 is also 55. Okay? So any way you do that. So if you know the big angle and you know one little angle, you know the other one. If I subtract the big one minus the little one I already got, that gives me the other little one. It's a good job. So that's the good thing about geometry, is a lot of times there's more than one way to do it. Can y'all do this one with me without drawing the picture? Y'all do this one with me without drawing the picture? Will that take some time? What kind of angle is that? The whole thing is a right angle, right? Which is 90 degrees, correct. So, how am I going to first of all find x? Little plus little equals big. We know the whole thing is 90, so that's the big one. So, tell me one of the little ones. Plus 2 plus x plus 1 equals what? 90, because the whole thing equals 90. Little plus little equals big. So, add your x's. What's 2x plus 1x? 3x. What is 2 plus 1? Equals 90. How do I solve that for x now? And then 3x equals 87. Divide by 3. X equals 29. Good. I'm gonna plug it into that one because that one looks really easy. And that's HFG, isn't it? What's 29 plus 1? 30 degrees. Okay, y'all, if this one's 30 degrees, how can we get this one? Yeah, you can say 2 times 29 plus 2. Or what else could you do? 90 minus 30 will tell me the leftover, which is what? This one has to be 60. So measure of angle EFH equals 60. And we got that 90 minus 30. Yeah, you got a question? You good? So we could plug 29 in there and check, right? Right? 2 times 29 is 58, I believe. 58 plus 2 is 60. There you go. Good job. Excellent, excellent, excellent. Can y'all try that one? You don't have to draw it. Just try it. It tells you the big one is 72. Find the 2 little ones. Thank you. Yeah, drop them on the card up there. Shh. I'm writing your assignment for you, Zane. Have a good weekend. Yeah, put them right there. Thank you. All right, go ahead and check them with somebody if you need to, if you're done. Do what? One more thing I gotta tell you. Well, that and you're getting more used to seeing the figures and figuring out pieces and stuff like that too. So yeah, it's supposed to seem It's supposed to seem hard at the beginning and then get simpler as we go along. You'll get used to geometry. Y'all just start using geometry. And I realized that. That's why I decided not to give y'all quiz yet. Just actually get a little bit more. Alright, did you set it? You got to set it equal to 72. It tells you X, Y, Z, which is the big one is 72. So, yeah. Say this is the little angle plus little angle. Say this is a little angle right here. This is a little angle. And together they make the big one. Does that make sense? This little angle is from here to here. This one's from here to here. Together they make the whole thing. Smaller than the whole one. I'm calling the big one the whole thing. There's three angles here. This little part, and then the whole thing. Okay? Yeah, you missed that part of that. Yeah, so you're going to say this plus this equals 72. So combine your x's, then combine your constant terms without variables, and then you'll move everything away from x. Yeah, you was moving stuff and you didn't have the equal sign. Okay, so you're just combine your like 3x plus 2x is 5x. And 6 minus 9 is minus 3. And then you add 3 and then divide by 5 and you'll get it. Because you didn't have it set up correctly. Because with the 72 makes a difference. All right, y'all. Tell me how we set this up to solve it. Let me unfreeze you. Tell me. Very good. Did everybody get the setup? Little plus little equals big. Or if you can think of it, little plus little equals the whole thing, right? And it told me right there that was 72 degrees, the whole thing, x, y, z. All right. So like terms, we've got 3x plus 2x is what? And then 6 minus 9 is what? Minus 3 equals 72. Now what? Yeah, we're going to move everything away from x. So add 3. 5x equals, and then divide by 5, and x equals. Am I done? No, it wants the measure of angle XYW, which is the top one, and the measure of ZYW, which is the bottom one. Which one did y'all find first? Measure of angle XYW is the top one. So I'm going to say 3 times my x is 15 plus 6. What's 3 times 15? 25 plus 6 is what? 51 degrees, because it's measure of an angle. So this one's 51 degrees. So I've got 2 ways I can find the other angle. How could I do it? I can say 2 times 15 minus 9. Or I can say 72 minus 51 to tell me the leftover, right? Either way, hang on, Z, Y, W. Either way, I should get the same thing. So I like to do it one way, then check it the other. So 2 times 15 minus 9 is pretty simple. 30 minus 9 is what? 21 degrees. Did y'all get 21 degrees? And I can check it. If I add 51 plus 21, do I get 72? Yes. Very good. Who got 51 and 21? Awesome job, y'all. All right, the last thing I want to talk to you about real quick, and I'll do that later, is an angle bisector. We talked about a bisector yesterday, right? Please write down this definition. It's the last thing we're talking about. Last thing, I promise. Yeah, but you're needing your notes too. This screen is the last thing you're going to have to copy today, I promise. I promise. All right, so yesterday we talked about a segment bisector, and that a segment bisector divided a segment in exactly 2 congruent segments. It divided exactly in a half. Well, an angle bisector is going to be the same thing. It's a ray that cuts through an angle in exactly the middle to divide a large angle into 2 congruent parts. Okay? So it's going to divide an angle into two halves.
Miss Isbell,
Yes.
Plain English needs to come to office, please check him out.
He did a long time ago.
Did he leave?
A while ago.
Okay, thank you.
Okay, so let's look at this picture right here. So a bisector, like I told you, divides it in half. Divides an angle at exactly a half. It says ray YW, which is this ray right here, it's going through the middle, bisects angle XYZ, and so XYZ is the big angle, okay? And the measure of angle XYW, this little part, is 18 degrees. You've got to read the letters and find out which angle it's talking about. So, it told me the word bisects. That's an important word. And I drew in my picture that this part's 18 degrees. So what does bisect mean? It makes two congruent pieces, right? So if this little angle is 18 degrees, then this little angle is 18 degrees as well, correct? All right? That's what bisect means. It makes two equal pieces. Find the measure of angle XYZ. Well, is XYZ a large angle or a little angle? It's the whole thing, right? So how am I going to get the measure of angle XYZ? You can add them together, or you can just double 18, right? 18 times 2 is the same thing as 18 plus 18, which is how many degrees? 36. Isn't it easy? You do have like 3 of these on your homework. That's it. So, what if they tell you the measure of the whole angle? How are you going to find a little one? Divided by 2. There you go. So if they give you a little one, you double it. They give you a whole one, divide by 2. But you're going to have to read the letters. Okay? You're going to have to read the letters. All right, we're ignoring that. Here's my own problems. Page. Oh, sugar. I don't want to write with that. Page 29. 7 through 10. This is not as many as it was yesterday. And I think they're a little easier today, honestly. And then 29 through 31. No, it's not even. That's like 4 problems, that's like 6 problems, and that's like 3 problems. So that's 13 altogether. Not when you have 30 minutes of class? Yes. I'm still recording. Y'all have a good day.